Just answering questions with Lab Tech. A set of questions, one of them on the ergonomics and biology of animals and pseudo measurement systems, including the ones humans use. One of them on vacuums and what that word really means and grades of vacuum. And a thought experiment involving a vacuum cleaner because we're on a vacuum kick. So here we go. I'm sure that building a decent nest or structure or shelter by carrying twigs and other materials of varying sizes and weights over a certain distance would be something to be proud of. So, would the measurements of weight and distance be discussed with others between ants or birds, for that matter, as well as humans, obviously? I'm going to bring up a couple of things here, but do animals or insects communicate building instructions? Now, it's not outside the realm of possibility. I mean, human beings are blind mice looking at an elephant and deciding it has to be a caribou. But we humans communicate a high level language, but you can look at older communications being hand signs, pantomime, that sort of thing. So, do insects and or birds or animals do it? I'm going to state factually that chimpanzees and gibbons and all sorts of creatures will use twigs and full on make tools and use them and watch each other do it, if not demonstrating to each other as a form of communication, explaining exactly how to do certain things. This has been seen in high order animals, and humans obviously can do this. And even human beings who grow up in an environment where there are no languages taught, during the language learning phase, which is this weird period of time where anybody can learn French, God help us all, human beings will invent a language to communicate things. It's inevitable. But do birds or ants do it? The answer is not really likely, but they could. No joke, they could. I'm sorry, watch a crow or a raven in your area learn how to open up a box because they want a fucking peanut. We're lucky we get to run the planet for right now. I'm sorry. And don't even bring up the squirrels and beaver damming. But do they communicate this information? They do it by demonstration and imitation. Primarily imitation, but then by demonstration. I've watched mama squirrel show baby squirrels how to make a nest. It's just the rudimentary starting point, but then when they habitually repeat it and keep building it, they end up figuring out, oh, I can just pull in the top and make a nest ball. They just do. Or they just make a pile of twigs and burrow into it and then pack the surface, and then they build the nest from the inside out. Most of you don't even know how to do that. That's how you make an emergency shelter. You build a pile of material that will deflect the wind first, rain second, and then you line it with something fluffy that will shed water. You're going to have to take survival school to learn that. And it's a debris shelter. Ants will measure things simply using their body dimensions. A leafcutter ant, not all of them, will make a leaf the same size as their maximum width that they can stretch out their body. They just use that as a measurement and then just keep going along and feel the edge they've nibbled at until they get the leaf cut loose. At the same time, they also use their legs to hang on to what's left of the leaf they're on, so when they break it loose, they can grab the edge and pull themselves in. If they fall with a leaf, ants can tolerate dropping the equivalent to 2 miles by human standards, so they don't really have to care, but they try to avoid it. Other ants do another thing where they'll cut them much bigger or much smaller, or just cut the whole leaf off, and then they'll have a bunch of them waiting on the ground to pick up the freshly cut leaf. They detect that it's been cut by one of their own friends, and then they drag it back to the nest for further processing because they're greedy. Is this communicated, or is this something that's a learned behavior, or is this something in their case where if they do one of the behaviors, they're that type of leaf cutter, and if they do the other behavior, they're the other kind? There are some nests you'll find where leaves are cut in different ways because that is the root population that causes the others, because some of them will cut big and some will cut small leaves. So is this communicated or learned behavior? Did they discuss it? With the exception of bees literally communicating navigation data, which when humans figured that out, we're like, okay, we're probably dealing with a very advanced species. Except for hive populations, like ants, most insects don't communicate with each other, but some do. Bats communicate. You can watch murmurations of birds flying in formations that almost exactly match air pressure ratios. Yeah, look that up. That was an interesting science study. So do they communicate in the way you and I would think? Probably not. Do they communicate? Shit, yeah, they do. Do they communicate weights and measures? They do by their own dimensions. Remember, in our current metric system and science system, we base everything on absolutes we can't detect, like basing on speed of light or the number of cycles per second done by a particular atom, fine line transition of hydrogen, things you'd have to know how to detect in the first place to decide that's how you're going to measure the second. I'm not sure we have practical measurements, but this is also the reason we use cubits for figuring out the size of doorways. Check it out. Many of your doorways may be an exact multiple of the number of fingertip to elbow span, or maybe knee height. You might notice that all of your chairs are almost exactly 1 inch taller than the distance between the back of your knee to the floor when you have your foot laid down. Because that's required for the chairs to work, because they have to be made to human standards. They're not meant to some arbitrary standard of meters. What happens to sound or any other vibration once it hits the vacuum of space, or any vacuum? Is there such a thing as 100% vacuum space in the universe anyway? Okay, these are the dumb ratios I have. They're not accurate. They're generalities. Around every planet, most planets, is some atmosphere or some gas collection simply because of gravity. It can be extremely mild or very dense, anywhere from Venus to Mars. But it can be a real atmosphere. This also accounts for the reason I use 8,000 miles across as the dimension for the Earth when that's clearly wrong. I'm counting the atmosphere as being part of Earth, because it basically is. And it's also, I choose to use that as our realm. Between planets, interplanetary space, there's also a separate one, interlunar space, which is the gas layer between the Earth and the Moon, which is usually a ribbon that's kind of torqued, but there's an extra pressure level there. But interplanetary space has a specific vacuum rating, meaning how far apart hydrogen atoms are. Let's say they're 5 centimeters to 10 centimeters. And then we have interstellar space between solar systems. Now, this is the space directly in the middle of them, not just outside of some arbitrary limit. We use the bow shock on one side of our solar system, which you would arbitrarily call the north end, from my perspective. And the south end is the trailing edge, or the comet tail of not the bow shock. That is the outer limit for our solar system as far as the gas pressure level and the plasma layer and a bunch of other something dark side. It's also called the heliosphere or whatever. That limit also represents a pressure difference, and it drops off between stars right outside of that, but we want to measure between them so we can get a nice average of the hydrogen atoms being much further apart, like let's say half a meter or something like that. It could be any distance. We'll just arbitrarily say it's more than 10 centimeters apart, 100 millimeters. Then we get intergalactic space. This is caused by something you might not realize. Obviously, all of these are based on the gravity of these planets or star systems, or the outburst of gases from them competing with that, having different densities of how far apart hydrogen atoms are, helium atoms, or whatever. And these are atoms of gas that can have a retarding effect on something moving very fast or on something that's very large. This is also the basis for the solar wind. Some of it's not just energy, it's gas, plasma. But in between galaxies, the pressure level is so low that you could have atoms that could be many meters apart or a kilometer apart, depending on how far apart they are. We don't have the way of really experimentally testing it. Now, one of the things you'll hear a bunch of flat earthers talk about is, well, it's more of a vacuum than a vacuum, therefore it's a negative number or some other thing, or it's 1,000 times more of a vacuum. If you're measuring the air pressure that would affect a human head, and all the atoms are always this far apart or further, pulling them further apart isn't a larger vacuum. This is an absolute vacuum, and if one atom or another, or even both, press against you, it does not add enough pressure to be measurable. So yes, there is 100% vacuum, and you can make one on Earth nearly perfectly the same thing. Nearly perfect is a conceit or scientific conceit that it's not truly a vacuum. That doesn't mean it's any different in any practical way. It's still 15 psi when we measure the vacuum you can make here on Earth in a container versus the vacuum you get on the Voyager probes or a vacuum you get on the moon. The vacuum difference of one atom versus two atoms within your measurement criteria does not add enough mass or pressure to be detectable. They are all 100% vacuums because it's the difference between 100% vacuum and 99 point, and it's like 1,009%. It's not significant enough to make an interesting statement. However, at high speed, we're talking a tenth the speed of the light or faster, or something very large like an asteroid. The amount of atoms it runs into in space does have a degrading effect over thousands of years and is measurable, or at least calculatable. But it's based on the total mass hitting it over 1,000 years when the atoms are literally this far apart and they weigh an atom. So yes, you can have a 100% vacuum in space, whether it's intergalactic space, interstellar space, or interplanetary space, and also interlunar space between the planet and the moon. I think that's what it's referred to as. Next, if someone was to place a vacuum cleaner inside of a fully vacuum-sealed cubic meter cured glass resin box with an electric cord hanging out and it turned on while not plugged in, what would happen if you plugged it in? Now this one is a confusion because it introduces the cured glass resin. Glass resin isn't a thing. Resin glass or plexiglass, completely cured or fully cured, a vacuum sealed container with the cord hanging out and a vacuum cleaner sitting in it. Are you talking about the box being a pulled vacuum with a vacuum cleaner in it? If you are, then the vacuum cleaner would run much faster than it would in air because it's not doing any work. It's not pushing anything. It's simply spinning the blades or whatever the equivalent is, and it's having no airflow to affect it. You can test this by taking a vacuum cleaner and stopping it from having airflow in. This creates a lower pressure level, not a high vacuum, obviously, and this causes the vacuum cleaner to speed up. You can find out the absolute maximum speed in a vacuum chamber by just putting one in there and plugging it like you're talking about. It'll run faster in the lower pressure atmosphere and or in a pulled vacuum. Also, because it might be touching the box, you could even hear the frequency of it. And might fill itself faster if you had liquid resin of a low enough viscosity. If you were pouring liquid resin in a 1 cubic meter box, what it would do is it would pull the resin through, burp out all the air, and as long as the motor could tolerate being submerged in some sort of liquid at all, number one, and number two, if it could tolerate it electrically so it could still work. For instance, there are motors that don't require the electrical contacts between the rotating part and the non-rotating part, the stator versus armature. The motor must be able to tolerate the environment it's in. Next, you could have a given cast resin viscosity versus a dry vacuum cleaner versus a wet dry vacuum cleaner. Wet dry vacuum cleaners are designed to tolerate all sorts of crazy crap and might truly be able to do this quite easily as an experiment. A very small Kirby, the one with a little snorkel sticking out, could be a good one for this experiment. And if you did it as a vacuum chamber, you'd be able to probably hear through the body of it that the frequency went up in pitch. But you can also just plug on the end and hear it go up in frequency, cycle per second. And if you wanted to, you could fill it up with any liquid at lower viscosity than the resin and see what it would do, and then just run it at a lower speed on your video playback to see what it would do in resin, if that's what you're talking about. But cured resin glass or glass resin isn't actually a thing unless you're talking about glass ionomer resin, which I don't know would be necessary for the discussion, but okay. Glass resin box would have higher strength and be able to tolerate a vacuum more. And if you're talking about doing this with glass resin fluid to be pumped through, it would have a higher viscosity and might degrade the material and actually damage the motor in the process and ruin the experiment. So, depending on what you're asking, I hope I've answered the question, so here we go. If you dump it into a liquid, it'll run at a lower speed, but keep running and probably burp out the gases and maybe retain a few. If you're talking about a vacuum chamber, it should run at a higher rate and not really do anything with any of it and not accomplish anything. It might even overheat more because it's running faster, or lower. That would be an interesting experiment. And if you're talking about casting resin being dumped into a container and doing this, you'd have to lower the viscosity to where the motor would be able to completely do what you're doing for an experiment. Or you could just use water or some other much thinner material to test it in. You could also do an extremely heavy gas, preferably non-explosive, to do the experiment as well. And you'd be able to gain knowledge of it that the denser the gas or fluid or more viscous, the slower the motor goes, and the more close to a vacuum, the faster it goes. Which means the vacuum chamber would cause the vacuum to achieve maximum vacuum speed. Thank you for watching. Have a good day. Good luck with that.